Bienvenidos, Ushamadid, and welcome Anne Arundel Community College learners from the CTS-130 Section 402 course during the spring 2021 semester. This is the Cisco Networking Academy's ITNv7 or Introduction to Networks version 7 course curriculum, and in this supplemental video tutorial, we're going to be taking a look at how we can identify the IPv4 host portion of an address. Now, in the previous video, we looked at how we would identify the network portion of the address, and that's really all we need to do to figure out the host portion, because whatever's left over after we identify the network portion of the address is the host portion of the address. And again, we're dealing with classful boundaries here. So class A is a /8, where the first 8 bits represent the network portion. Class B is a /16. Class C is a /24, and so forth and so on. So let's dive into the activity. And let's try to make this a little more difficult this time, a little more challenging, shall we say, by not drawing up a little chart over here with Class A, Class B, and Class C. Let's simply take a look at the questions and see if we can come up with the answers. So our first one is 198. Now remember that 192, which is a very popular address block, 192.168, that we'll be using here as we enter our CCNA studies, that is a Class C address, and that range is 192 to 223. So we know that this is going to be a Class C, meaning at the classful boundary, the first 24 bits or the first 3 octets represent the network portion of the address. And whatever we have left over, that's the host portion. So the correct answer here would be .110. That's the host portion of the address, the last 8 bits, that last octet. So now we come down to one that might be a little more challenging here, right? 216. It's going to make us stop and think, but we know that that Class C range is 192 to 223. And so if we look at this again, we say, yep, it's a Class C address. The first 3 octets, the first 24 bits, remember there's 8 bits in each octet. The first 24 bits are the network portion of the address, meaning the host portion is the final 8 bits, and that value would be .65. So let's come now down to number 13. Well, if the Class C begins at 193, we know that this is probably not a C, it's probably going to be a B. And then we just need to remember that the Class B start at 128. And so Class B, meaning /16 for a classful subnet mask, is going to be the first 16 bits or the first 2 octets of the address are the network portion. And whatever we have left over would be the host portion. So .115.2. And that's the answer for number 13. So let's clear the screen here. And let's scroll down to question number 14. Let's see if we can get 14 and all the way down to 17 in the same frame. So 119, if we think about that, remember we said that the Class B starts at a 128. So when I look at this, I can clearly see that this is going to be a Class A address. And the classful network boundary for a Class A is a /8, where only the first octet represents the network portion of the address, the first 8 bits. Then the remaining 24 bits, because remember, in IPv4, our addresses are 32-bit values in dotted decimal notation here. There's 32 bits involved, and they're broken up by dotted decimal notation when we write the decimal values out. The last 24 bits, the last 3 octets, that is the host portion. So 82.51.43. And then we come to question number 15, and we see 199, and again, that 192, 168 that we like to work with, this should be setting alarm bells off. It's going to be a Class C, meaning the first 24 bits belong to the network portion of the address, and only the last 8 bits belong to the host portion of the address. And in a Class C, because the last 8 bits on a /24 classful network boundary, the last 8 bits can represent the hosts. That means we would have 2 to the 8 possible IP addresses. Now, I didn't say usable IPs or assignable IPs. Total, we're going to have 256 possible addresses. Think about it. It could go from 0 up to 255. And that's kind of a bad 5 in there, but this last octet could be a range in values from 0 to 255. So we could have 256 possible addresses, of which, with a /24, we subtract 2, meaning the usable IPs that I could assign to devices in this network, if it's a /24 on the classful subnet boundary here, network boundary, I would have 254 possible assignable IPs that I could assign to my access points, my laptops, my desktops, my servers. And the 2 addresses that we subtracted here will be the subnet ID, and it's also referred to as the network ID, and the broadcast address. And I'll just put bcast here. So these are the 2 networks that are the 2 IPs in this network that we can't use because they're already spoken for. So keep that in mind. So the whole host portion here is .55. Now we come down to the 192. This should be an easy one, right? Because we know 192s are Class Cs, the first 24 bits in a classful scenario. And then we would have .5 as the host portion. So these are the network bits. Whatever remains going from left to right, those are the host bits. Now we come down to the 10 dot. Again, another RFC 1918 block of addresses. So this would be a Class A. That is the network portion of the address, the first octet, the first 8 bits, meaning our answer for the host portion is going to be 255.10.1. Let me get rid of those last 2 periods there. They got out of the way. .1. All right, and that would be the host portion. And if you're thinking, well, wait a second, up here with the Class C, when you did this little 2 to the 8 thing and came up with that number of total IPs and then subtracted 2 to get the usable of 254, does that work with this down here? And it does. It's just that the number is going to be much, much larger. In fact, if we were to take a look at that, we would say 2 to the 24, right? Because we have 24 host bits here. The last 3 octets are the host portion of the address. And so 2 to the 24, and my math skills are definitely not that good, so let's pull out the calculator here. And in fact, I'm not sure my calculator skills are going to be able to get this done. Let's see with the basic is not going to let me do what I need to do. What about the scientific? Yeah, let's see if we've got it here. So if I was to say 2, and I think we want to do to the 24, and there's the number. So that is in a classful Class A subnet scenario, a /8, where only the first 8 bits, the first octet, represent the network portion of the address. In that scenario, the host portion of the address is going to leave behind or give us 16,777,216 IPs. And I'm not going to write the number down here, but if I was to do that, whatever, that 16 million number minus 2, that would give me the total usable. So it would be 16,777,214 usable IP addresses. Kind of crazy when you think about it, right? And when you look at this example, and the reason I waited to get here to start to draw things like this out is, let me ask you, do you want to have a broadcast domain, a network that large with 16 million devices? Probably not. But if you wanted to use 10.whatever.whatever.whatever, we would want to subnet. And that's where, again, we start to borrow the host bits so that we can have more subnets, more networks. We want to create more networks, because think about that. If you're scratching your head thinking, wow, I don't need 16 million usable, 16 million and change usable IP addresses. I need like 50. But I like using 10.something.something, then you would subnet. Borrow from the host bits. Take the host bits away so there are fewer host bits and more network bits. And that's really what subnetting's all about. And it was all brought about to conserve IPv4 addresses. All right, so we'll go ahead and come down to 18, 19, and 20 here before we move on to our next set. Again, 222 right on the boundary of the Class C and the Class D, but we know that it's 192 to 223, so the host portion of the address is going to be a 151. We come down here, 128. Now remember, this one's a little tricky because we said it's from 1 to 126 and then 128, because 127, those are those loopback addresses that we do not use when we're doing routing, right? So 128 would be the Class B, right? That first value in the Class B range, 128. So it would be a /16. And if you're wondering, well, there's 16 bits left over here, 2 full octets to represent the host portion of the network. So my answer is 126.3, but my question to you is, we're going to pull the calculator out here, 2 to the 16, how many IP addresses would we have if we were using a classful subnet mask, a /16? And that would be easy for us to figure out. We would come over here and say 2, we're going to raise it to the power of 16, and that's going to give me 65,536. I didn't say usable, available, right? Total IP, 65,536. Now, we know that we subtract 2 to get to the usables, which are going to give us 65,534. But again, let me ballpark the number here, 65,500 IPs in a single subnet? Are you really going to need that many IPs? And the answer is probably not. Even at the CCIE level, you're usually not dealing with networks where you have 65,000 IPs in a single subnet. And so what do we do here? If we want to use the 128, we start to borrow, going from left to right, the host bits, and we take those and use those for the network portion of the address so that we can right size or shrink and adjust the size of the number of available IPs in the network. All right. So let's come down to number 20, the last one here, which is 203. Well, we know that that's going to be in that Class C range, 192 to 223, meaning my answer will be 253. That is the host portion of the address. The first 3 octets, the first 24 bits, that is the network portion of the address. Again, we're talking about classful boundaries in terms of the subnetting. And again, this is kind of going to slow walk us into what happens when we start to subnet. All right, well, let's clear the screen. Those were the answers. And that is going to do it for this activity on identifying the IPv4 host portion of an address in a scenario where we're working with classful boundaries. All right, thanks so much for watching, and I hope to see you in the next video.